Good evening, everyone. My name is Dalton Milnes, and this is my solution to problem 1 from this week's homework. I chose problem 1 not just because it was the first problem that I did, but I believe that it introduces and it incorporates a lot of the key elements from this chapter. So let's just get right into it. The question gives us a diagram of electric field lines, and it poses the question: in the figure, the electric field lines on the left have twice the separation as those on the right. A, if the magnitude of the field at A is 39 newtons per coulomb, what is the magnitude of force on a proton at A? And B, what is the magnitude of the field at B? So before we get into our solution, let's go over some of the important concepts and formulas from this chapter. The formula we'll be using is the formula for a point charge in an electric field, which is F equals QE. F is the electrostatic force on a charged particle, Q, located in an external electric field, E. And it's important to note that a particle is not affected by its own field, which is why we use the word external. And then Q is the charge of the particle with a positive or a negative sign. And it is important to note that a positive Q, the electrostatic force will be in the direction of the electric field. And for a negative Q, the electrostatic force will be opposite that of the electric field. So also important to note, our significant figures are 2 for this problem. And yeah, after going over that stuff, let's go into the solution. I start by listing my knowns. Given in the problem that the magnitude of the electric field is 39 newtons per coulomb at A, and the charge Q is not given to us in the problem specifically, but it says that it's a proton, and we know from the last chapter that the elementary charge is 1.6 times 10 to the negative 19th coulombs, and it's positive because it's a proton. So yeah, let's just go right into part A. It's pretty simple. We just plug our knowns into the formula for a point charge in an electric field and solve. So F equals QE equals Q, 1.6 times 10 to the negative 19th coulombs, times the elementary charge. Oh, I'm sorry, no, that's the elementary charge. It's 39 newtons per coulomb for the electric field. Multiplying those together, we get 6.2 times 10 to the negative 18ths newtons. And we get newtons because the coulombs cancel out. For part B, this is kind of a conceptual problem, but it's important to note that in an electric field, the closer the field lines are together, the stronger the field. And that's for point A. It says in the problem that point B has twice the separation as point A, which means that A is twice as close together, and therefore will have twice the magnitude. So set up an equation. A equals 2B, B goes to B equals A over 2, and then we plug in our known for A. So B equals 39 over 2 newtons per coulomb, which is 19.5. And then since we are using 2 significant figures, the correct answer is 20 newtons per coulomb. And that concludes the answer to part A and B of question 1 for this week's homework. And with that, I'll give you a little tour here. There's Ralph Waldo Emerson, the rabbit, and 2 dogs that have been patiently waiting the whole time. Good dogs.